When we solve complex problems, we often jot down brief keywords or calculation steps on paper rather than recording every thought process in detail. Now, researchers have found that allowing AI to adopt this approach can increase reasoning speed by 13 times. This research from the Zoom team demonstrates a new mode of AI thinking. Hello everyone, this video is about a paper published on AR's titled Chain of Draft, Thinking Faster by Writing Less. This paper proposes a method called Chain of Draft, Draft Chain of Thought, which significantly improves the reasoning efficiency of large language models, LLMs, by mimicking the concise thinking process of humans. Before introducing Chain of Draft, let's first understand in detail how large language models currently perform reasoning. The mainstream method today is Chain of Thought, which requires the model to record each reasoning step in detail, like writing an essay. Let's illustrate this with a simple example. Suppose there's a problem. Jason has 20 lollipops. He gave some lollipops to Denny. Now Jason has 12 lollipops left. How many lollipops did Jason give to Denny? Using the traditional method standard, the model directly gives the answer 8. Although the answer is correct, we do not know how the model arrived at this result. Using the chain of thought method, the model would think like this. 1. Initial state, Jason has 20 lollipops. 2. Current state, after giving some to Denny, there are 12 lollipops left. 3. Problem-solving approach. The difference between the initial quantity and the remaining quantity needs to be calculated. 4. Problem-solving method, use subtraction, initial quantity, remaining quantity equals given quantity, 5. Specific calculation, 20 to 12 equals given quantity, 6. Final result, the calculation yields 20 minus 12 is equal to 8. This detailed reasoning process indeed helps the model improve accuracy, but the problem is, it's too verbose. It's like a student writing too many unnecessary steps when solving a problem. This method generates a large amount of lengthy intermediate output, leading to slow reasoning speed and high computational costs. Chain of Draft, Draft Chain of Thought, adopts a method that is closer to the actual way humans think. For the same problem, its reasoning process will be much simpler. 20x equals 12, x equals 20 to 12. X equals 20 to 12 equals 8. This concise process contains all the necessary information using x to represent the number of lollipops given, setting up the equation to show that 20 minus the number given equals to type. This is the essence of Chain of Draft. It preserves the integrity of reasoning, but removes all unnecessary textual descriptions. Just like when we solve problems on draft paper, we usually only write down the key equations and calculation steps and don't write a large paragraph to explain each step. To comprehensively verify the effectiveness of Chain of Draft, the researchers designed a series of rigorous experiments. They selected 3 different types of reasoning tasks, each representing common challenges AI systems face in practical applications. First is the arithmetic reasoning task, which requires the model to solve various mathematical word problems. For example, the lollipop example we mentioned earlier belongs to this type of problem. In this type of task, Chain of Draft performs excellently. It can list key equations and calculation steps in the most concise way, just like the draft calculations a math teacher does when grading homework. The second category is common sense reasoning tasks. This type of task tests the model's understanding and judgment ability in daily life situations. For example, judging the causal relationship such as if it rains, the ground will be wet. In this type of task, Chain of Draft also demonstrates its advantages, being able to capture the core logical relationships in the situation with brief keywords. The third category is symbolic reasoning tasks. This type of task requires handling more abstract logic and symbolic operations. Let's look at a simple example. Suppose there is a question like this. A coin starts with heads up. Yao Ming flipped the coin once, Zhao Hong flipped it again, and finally Zhao Hong also flipped it once. Although Yao Mei was present, she did not flip the coin. Ask whether the coin is heads up or tails up at the end. If using the traditional chain of thought method, the model needs to describe each step in detail. First, the coin is heads up. After Xiao Ming flips it, it becomes tails up. And after Xiao Hong flips it, it returns to heads up. Finally, Zhao Hua flips it to make it tails up. And Xiao Mei does not flip it, so it ends up tails up. This description is clear, but also very lengthy. By using the chain of draft method, The entire reasoning process can be simplified to front, flip, back, flip, front, flip, back. It's that simple. This way of expression not only preserves the complete reasoning chain, but also greatly improves efficiency. This is the advantage of symbolic reasoning expressing complete logic with the most concise symbols. Research shows that this simplified method of chain of draft not only did not affect accuracy, but in some cases performed even better. More importantly, it reduced token usage to 7.6% of the original, equivalent to a 13-fold increase in inference speed. This significant efficiency improvement is a major benefit for applications requiring real-time interaction and scenarios involving large-scale deployment course, this technology still needs to be perfected. For example, when dealing with particularly complex problems, detailed reasoning steps may still be required, but its potential is obvious. By imitating the way humans think concisely, Chain of Draft shows us a new path to improve the efficiency of AI systems. In the future, it may also be combined with other technologies such as parallel reasoning to further enhance the practical value of AI systems. That's all for this video. If you found it helpful, please like and subscribe. See you in the next one.